Choksi. I am Assistant Professor in LGIT. Student, welcome to session number 2 of area and volume. In this session, student, I have explained how to find the boundary area from trapezoidal rule as well as the Simpson rule. Student, in a previous session, I have explained how to find the boundary area from mid ordinate and average ordinate. But here, in this particular session, I have explained about how to find the boundary area or calculation of the boundary area of this method, carried out these two methods. One is a trapezoidal rule as well as the Simpson rule. So student, please give attention. This is a two important method for found the boundary area. So carefully listen and uh, please you have take the one blank page and draw the figure as well as you have derived the equation. So you have clearly understand. So first trapezoidal rule. Here you know that this is a boundary line. You have considered the short straight boundary and joining the short straight boundary between the offset. You have taken the offset from any instrument. O1, O2, O3, O4, O5, O6 is the offset or ordinates. D is the common distance interval. You have already studied in a previous session. Now you have find the equation of boundary area from trapezoidal rule. So first, by applying the trapezoidal rule, boundary between the ends coordinates are assumed to be straight. I have already explained. Joining between the line O1 and O2, O2 to O3, you have assumed that the straight. Now, the area enclosed between the baseline and irregular boundary line are considered as a trapezoid. So this is you are considered as a trapezoid. So now you have find the area from particular trapezoid. So O1, O2, On is the ordinates, is the equal distance, equal intervals. D equal to common distance between two ordinates and L equal to length of the baseline. Now first area, you have considered the first area, this boundary, particularly this portion, you have find the O1 plus O2 divided by 2 into D. So here you know that the area of the trapezoidal, first ordinate plus last ordinate divided by 2 into D. Similar that second area, you have considered this portion, so O2 plus O3 divided by 2 into D. Because D is a common distance, same interval, so here you have considered into D. When different interval is given, so D1, D2, D3 are there, but here distance is same interval, so you have considered only small d. Similar that you have find the area of third area, fourth area up to n area. So last area equal to On minus 1 plus On divided by 2 into D. So now you have summation that, so total area equal to D by 2 is a common. So common is D by 2 in a bracket O1 plus 2O2 plus 2O3, because here you have summation that you have solve this formula. You have directly written in an exam, particularly this particularly formula. But when you have solved this formula, you have clearly understand 2O2 plus 2O3 plus 2O4 up to 2On minus 1 plus On. So here only O1 and O2 On is not a multiply by 2, so I will common that. So put the common O1 plus On means first ordinate plus last ordinate plus 2 in bracket sum of all the ordinates. So you know that 2 is a common, so O2 plus O3 plus up to On minus 1. So I will repeat this term. You have summation that you clearly understand. It is easy. D by 2 common distance divided by 2. Here O1 and On only, not the multiplication with in a 2. So I have taken a common. So O1 plus On and all the other ordinates are multiplied by 2. So 2 is a common and O2 plus O3 up to On minus 1. So this is a final formula, common distance divided by 2 in a bracket first ordinate plus last ordinate plus 2 in bracket sum of the all the ordinates. So O2 plus O3 up to On minus 1. So this is a formula of trapezoidal rule. So how to write? So area equal to common distance in a bracket first ordinate plus last ordinate plus 2 in bracket sum of other ordinates divided by 2. So remember this formula for finding the boundary area. I have taken an example as in a particular session, so you clearly understand. So the trapezoidal rule may be stated as a follow: the sum of the first ordinate and last ordinate twice the sum of the intermediate ordinates is added, and the total sum is multiplied by the common distance, and half of this product is required area. So you have stated as a follow. So here limitation is there is a no limitation for this rule, because this rule can be applied for any number of ordinates. There are two types of that even ordinates or odd ordinates, but in a trapezoidal rule particularly no limitation are there. This rule can be applied for any number of ordinates, even or odd. Here I have taken 6 ordinates. So 1, 2, 3, 4, 5 and 6. So these are even ordinates. So here I have taken the odd ordinates, any type of ordinates, but this rule is can be applied. So this is our equation. I will repeat this equation: d by 2 in a bracket first ordinate plus last ordinate plus 2 in bracket sum of the remaining ordinates. Now after the understanding the trapezoidal rule, now second rule is a Simpson rule. So here this rule is different because in this rule the boundary between the ends of ordinate are assumed to from an arc of parabola. So here you have clearly seen in this image O1 and O2 joining with straight line, but here O1, O2 and O3 joining with in a parabola. So I repeat this particular line. In this rule, the boundaries between the end of coordinate are assumed to from an arc of parabola. Here clearly the boundary are joining in an arc of parabola. Hence, Simpson rule is sometimes called as a parabolic rule. So this Simpson rule is also known as the parabolic rule. But here one limitation are there, student. Clearly listen, understanding. Here when you have joined the boundary line in a curve form or in a parabolic curve, so there are means three ordinates are used. So always Simpson rule is used for only odd ordinates. So here O1, O2 and O3. So joining the parabola is joining between the O1 to O3. So one limitation are that Simpson rule is only used for odd ordinates. I have explained in a next slide in a detail, but I have explained and derived this equation of for finding the boundary area depending upon the Simpson rule. So here our boundary is or coordinates is O1, O2 and O3, distance common interval distance D, the boundary joining between O2, O1, O2 and O3 in a parabola form, means in a curve form. Now you have find the particularly boundary area from this figure. So I have explained in detail in a simplified form. First you know that O1, O2, O3 three consecutive ordinates, D equal to common distance between the ordinates. Now you have find the area A, F, E, D, C and A. So you have find the area particularly A, F, E, D, C and A. So now you know that how to find the area. So I have divided into two parts. First part is area of trapezoid, means trapezoidal A, F, D, C and A. So first A, F, D, C and A. And second area is area of segment F, E, D, E and F. So I have divided into two parts, so you have clearly understand and you have easy to find the area. So part 1 and part 2. So now part 1 area of trapezoidal, you know that you have already find particularly this formula. So when you have find the trapezoidal area, so first ordinate plus last ordinate means O1 plus O3 divided by 2 into 2D. 2D, why 2D? Because this is a D plus D. So you have directly written as a 2D. Now you have get the answer of area of trapezoidal, means trapezium. Now you have find the area of segment. So you have find the area of segment. So area of segment, you know that 2 by 3 into area of parallelogram. You have remembered this equation. You have already studied in a MOS or in a 10-12 standard. Area of segment equal to 2 by 3 area of parallelogram. So what is a area of parallelogram? So you know that is the, I have taken one reference rectangle box is a parallelogram F, small f, D and capital D. So here F, small f, small d and capital D. So this is the area of parallelogram. Now you know that area of parallelogram equation is 2 by 3 into height into base. So here height is the EE and base is the FD. So height is a E and base already you have to know that 2D. So directly you have to write 2 by 3, height is a EE, here clearly seen this is a height, small e to capital E into 2D. So now only unknown are there, one unknown are there is a height of small e to capital E. So how to find? So you know that this is our figure O1 and O3. The distance is a O2 here. So you find the height is between the small e to capital E. So clearly you have understand O2 minus O1 plus O3 divided by 2, because this is the average you have taken. So first you have taken the O2 value minus you have averaged them O1 plus O3 divided by 2 and base is already 2D. So our equation is 2 by 3 small e to capital E into 2D. So how to find the small e to capital E? So our value is a O2. You know that our offset is a O2 minus you have take the average of O1 plus O3 divided by 2. So you have find the small e to capital E. So now summation of this particular two area, you have find the area from trapezoid is O1 plus O3 divided by 2 into 2D, and from area from segment you have find the 2 by 3 into O2 minus O1 plus O3 divided by 2 into 2D. Now you have add them because our main goal is to find the area of AFEDCA. So now summation that and find the particularly area 1 is d by 3 O1 plus O2 plus O3. You have not find in a particular GQ exam, you have only find in at a home. You have directly written particular this equation d by 3 O1 plus 4O2 plus O3. But you have tried to solve and simplify the equation and get the answer d by 3 O1 plus 4O2 plus O3. Now student, you know that similar I have assumed that I have taken the next two division means O4 and O5. So our equation is d by 3 O3 plus 4O4 plus O5 and so on. So you have directly written as a formula total area equal to d by 3 first ordinate plus last ordinate, because you know that here O1 plus On plus 4 in bracket sum of even ordinates. Why? Because here clearly seen 402 and get the answer 404. So in a ordinates of even ordinates, it is multiplied by the 4. So 4 is common. So O2 plus O4 and so on, plus here O3 plus here O3. So 2O3. So here in a odd ordinates, the multiply factor is a 2. So 2 is a common. So 2 in a bracket sum of remaining odd ordinates. Our final formula is you have remembered and you have write only directly, not in an exam, not to try to solve because time consuming. So here directly you have written a formula total area equal to d by 3 first ordinate plus last ordinate plus 4 in bracket sum of even ordinates plus 2 in a bracket sum of odd ordinates. So this is the equation for finding the boundary area from Simpson rule. I repeat this term, d by 3 means common distance by 3, first ordinate plus last ordinate plus 4 in bracket sum of even ordinates and sum 2 in bracket sum of odd ordinates. So this is the, I have repeat this term. First you have draw the for this figure, then you have separate part 1 and part 2 and try to find the area of trapezoidal plus area of segment, then add up them and try to find this formula, and you have written the directly the Simpson rule formula is total area equal to d by 3 plus 4 in bracket, sorry, d by 3 in a bracket first ordinate plus last ordinate plus 4 in bracket sum of even ordinates plus 2 in bracket sum of odd ordinates. So these are how to state it as a follow. You have here clearly seen to the sum of the first ordinate plus last ordinate, 4 times of the sum of even ordinates and twice the sum of remaining odd ordinates are added, and this total sum is multiplied by the common distance. And one third here in a trapezoidal, you remember that is a 1 by 2, but in a Simpson 1 by 3. So you consider one third of this product is required area. So what is the limitation? I have already explained. This rule is applicable only when the number of division is even. Sorry, odd. This rule is applicable only when the number is division is odd. I have written it mistakenly, so you have considered the only odd ordinates. Here, even, not even, only odd ordinates. So why odd ordinates? I will already say because the line joining between the offset is always in an odd form. So this particular rule always when the number of division is odd. So this rule is applicable when the number of ordinates is odd. These are, I have repeat this terms. These are mistakenly I have written here. Answer is odd. So now, what is the difference between them? Trapezoidal rule and Simpson rule. The boundary between the ordinates considered to be straight. Here, consider is to parabola. I have already explained. There is a no limitation, but here, to apply this rule, the number of ordinates must be odd. It a given approximate result and give a more accurately given result. Because here you have considered the boundary are joining in a curve form. So this is the difference between trapezoidal rule as well as the Simpson. Now I have taken one example, so you clearly understand. The following observer taken. Offset is given, interval is given 10 meter, means common distance is given a 10 meter. All the offset are taken 0, 2.50, 3.50, means ordinates or offset are given, and you have find the boundary area from trapezoidal rule as well as the Simpson rule. So now, student carefully listen. First step, draw the figure. I have already explained in a previous session all the example of mid ordinate and average ordinate. So first you have to draw the figure. Particularly this type of example, trapezoidal and Simpson rule. First you have count the number of ordinates. Here number of ordinates 1, 2, 3, 4, 5, 6 and 7. So no limitation are there because Simpson rule are used for odd ordinates. So here ordinates is odd. So particular this example not a issue because odd ordinates is a given is a in a odd form. So here first you have find the area from trapezoidal rule. So common distance in a bracket first ordinate plus last ordinate plus 2 in remaining 2 in bracket sum of other ordinates. So here you know that O1, O2, O3, O4, O5, O6, O7 is given. First ordinate is O1, so 0. Last ordinate is also 0. So D is a 10 divided by 2, means common distance divided by 2. First ordinate is 0, last ordinate is 0, plus 2 in the bracket, sum of remaining ordinates. So this is a sum of remaining ordinates. So answer will be 188 square meter. Now, similar that you have find the boundary area from Simpson rule. So d by 3, first ordinate plus last ordinate. So first ordinate is 0, last ordinate is 0, plus 4 in bracket sum of even ordinates. So even is at O2, O4 and O6. So only you have taken the O2, O4 and O6. So 2.50 plus 5.0 plus 3.20 plus 2 in bracket sum of remaining odd ordinates. Which are the odd ordinates? O3 and O5. O1 and O7 you have already taken. So 10 by total area is 10 by 3. 0 plus 0 first ordinate plus last ordinate plus 4 in bracket sum of even ordinates plus 2 in sum of plus 2 in bracket sum of odd ordinates. So odd ordinates is O3 plus O5. So 3.50 and plus 4.60. So get the answer of total area 196 square meter. So this example is based on Simpson rule in trapezoidal. Now you have particular this example exercise. Here one point are there. Here first the following observer taken it at 50-meter interval. So d equal to 15 meter student. Here uh, first you have count the ordinates. So here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here 10 means even number of ordinates given. So you know that particularly Simpson rule limitation. In a Simpson rule, particularly you have taken the odd ordinates. So but here in an example is given a even ordinates. So step number 1, draw the figure and find the trapezoidal rule. You all already explained in a previous session. D by 2, sorry, previous example, O1 plus On plus means first ordinate plus last ordinate plus 2 in bracket sum of remaining ordinates. So you have directly find the area from trapezoidal rule, because in a trapezoidal rule no limitation are there. But remember that particular Simpson rule, you know that number of ordinates must be odd in a particular Simpson rule. But here given the number of ordinates is even. So 10 is the 10 ordinates is given. So in particular this type of condition, clearly listen student, the Simpson rule is applied from only O1 to O9. So here ordinates is O1 to O9, and when you have find the area from O9 to O10, so you have considered the trapezoidal. So this type of condition, I will repeat this term, you have Simpson rule is only applied for odd ordinates. So you have taken the odd ordinates O1 to O9, and particularly second area you have find O9 to O10 is depending upon the trapezoidal. So here first, you have find the area 1 from Simpson rule. First ordinate plus last ordinate. D by 3, first ordinate plus last ordinate plus 4 in bracket sum of even ordinates plus 2 in bracket 2 plus 2 in bracket odd ordinates. So remember that here you have taken the, when you have taken the last ordinate, you have taken the O9, not O10, because Simpson rule are used only for odd ordinates. So O1 and O1 is the first ordinate and O9 is the last ordinate. Given 10 ordinates, but Simpson rule limitation only for the odd ordinates. So here you have taken the first ordinates is a O1 and last ordinates is a O9. So you have find the first area 1, then area 2 is found out by the trapezoidal rule. So what is the equation of trapezoidal rule? You know that d by 2 for first ordinate plus last ordinate. So first ordinate is a O9 and last ordinate is a O10. So you are directly 4.40 plus 3.25. So answer will be 57.38 square meter. Now you have find the total area A1 plus A2. So A1 is a 756 and A2 is a 57.38, and then summation that. So finally find the answer from Simpson. So the student, I have repeat this term, particularly this example. Here in an example, ordinates are given ordinates are given even form, but Simpson rule limitation, you know that only when you have using the Simpson rule only when the odd ordinates are there. So here you have considered O1 and O9 from Simpson rule, and O9 and O10 is considered from the and found the area from the trapezoidal. So you have given means you have divided into two parts. First you have find the area A1 from Simpson rule, and A2 part 2 is from found by the trapezoidal, and then add them A1 plus A2. In a first example, no did them. Why? Because here given the ordinates in a odd formula, means odd number is given. But particular second example, the interval or offset is given in a even form. So in this type of condition, you have taken the part 1 and part 2. So student, in this session I have explained about the derivation of trapezoidal rule as well as the example of trapezoidal rule, derivation of Simpson rule and example of the Simpson rule. So thank you so much for watching this video.